We have a population of gummy bears displaying 3 different phenotypes: 12 red, homozygous dominant, 6 green, heterozygous, and 2 yellow, homozygous recessive, for a total of 20 bears. Assuming that variation remains constant from generation to generation and selection does not occur, we can prove the population to be in equilibrium. We begin by finding the allele frequency, dividing the number of each allele by the total number of alleles. Because there are 20 bears in the population, each with 2 alleles, there are a total of 40 alleles. There are 12 red bears, each with 2 R alleles, and 6 heterozygous green bears, each with 1 R allele. We add up the total of R alleles, 12 from each allele in a homozygous dominant genotype, plus 6 from the R allele in the heterozygous genotype, divided by 40 to get a frequency of 0.75. Using the same equation, the allele frequency of the G allele is 0.25. Now that we've determined our allele frequency, we can plug it into the equation p squared plus 2pq plus q squared, where p equals 0.75 and q equals 0.25, to find the initial frequency of each genotype in the population. Because the frequencies add up to 1, we have confirmed that our population is in equilibrium. The allele frequencies will remain at equilibrium if all assumptions of the Hardy Weinberg law are met. In this case, natural selection favors the green bears as they are better able to blend in with their environment. Each genotype is awarded a fitness value and then multiplied by the initial frequency to determine the proportion of each genotype to survive after selection occurs. The fitness value awarded to the green bears is the highest because they are more likely to survive and reproduce than the red and yellow bears. To determine the frequency after selection, the genotypic proportion of survivors is divided by the average fitness to ensure the frequencies once again add up to 1. As you can see, the frequency of both the homozygous dominant and recessive groups has decreased after selection. However, the frequency of the heterozygous green bears has increased. This is distinct of stabilizing selection, where heterozygotes are favored. Both alleles remain in the population, leaving the possibility of red and yellow phenotypes in future offspring. If we take a look at the initial frequencies of the generation to follow, we can see there is not a drastic shift in the R and G allele frequencies. The R allele with a slight increase from 0.75 to 0.7588, and the G allele with a slight decrease from 0.25 to 0.2412. As selection continues over time, there will be a smaller range of phenotypes, the majority being heterozygous with the exception of a few on either end of the curve.